Hello, and welcome to your PreCal Chapter 1 review. I invited Jane along because, well, she's cute. And it's fun to have something else to look at. You will review functions, domain and range, identifying the graphs of a function, reading the graphs of a function, reading graphs, even and odd functions, increasing, decreasing, and constant functions, local and absolute, max and maximum of functions, transformations, so what is a function? A function is a relation that connects each element in X with only one element in the Y. Is this a function? Is this a function? How about the next one? Let's see if you can tell me if these are functions. Well, I guess the question would be, how would we even know? When the relationship only has one X, then we know it's a function. But if the X's are shared, it's not a function. For a graph, when we're looking at the vertical line test, if the line goes through the graph in 2 points, it's not a function. But if the line only goes in one, it is a function. So now let's look at these graphs. You notice how the line only went through once in most of them? So now we're going to look at the value of a function. How do we know what the value of a function is? When we see the terms f of x, we know that there's going to be something in those parentheses. It could be 3, 9, 157, or any number. You're going to take that number and plug it in wherever you see the x in the equation. And then you can complete the equation. It wasn't so simple when we started this class. Now we're looking at the difference quotient. Remember this? I sure do. But now when I look at it, I can see where all we're doing is plugging in the x plus h wherever we see the x and subtracting the equation of 3x minus 5. Now when we're looking for domain and range, this can get a little tacky because there's so many areas in which we can look for. But just know that the domain is the set of x and the range is the set of y. And whatever values you find that fill in those areas, you know where to place them. But don't work so hard. Any x value is going to give you a y value in that situation. So just go on and fill it in and find out what your y value comes out to be. Now here are some tidbits you can read so that you don't forget some of these very important parts. So now let's talk about adding, subtracting, multiplying, and dividing functions. We can take those functions that are separated and basically put them together. Once we've done that, we do the math, literally just do the math, and then put like terms together. Make sure when you're subtracting that you check out the negative signs. I usually have an issue with that. Now when we're multiplying these functions, We want to make sure that we FOIL them and get the correct answer. But again, all we're doing is taking the f of x and multiplying it by the g of x and plugging in the x. That's a very important part here. And then when you divide, you're going to do the same thing again. You're just going to plug in what f of x is. Now for
in this section,
I have
we
used
will
the same
review identifying the graph
equations
of
over
and
and over,
reading
just
the
to show
information the graph
that
is
we're just
given.
plugging them in.
So let's find the domain. Here we're going to look again on the x-axis. And for this we have the set of all real numbers because those ends are going out and going up and down, -4 to infinity. Sorry, I can't put the infinity sign in.
As we continue to read the graph, we're going to list the intercepts. You can see them popping up. And we're looking for points on the graph. Here's what's interesting. How many times does y equals 2 cross that graph? In our final set, we are still looking at the information on the graph. For what values of x does f of x equal to -2? And you'll see there, it's almost 0. Where is f of x less than 0? And you'll see there at the -3. And then we're going to find the zeros of the function, which means where are the numbers equaling 0 on the x-axis. And there you go. So this section goes a little quickly. We're going to look at even and odd functions. Even functions turn out to be positive even when they start out negative, and odd functions end up negative for the entire function at the end. Even are symmetric to the y-axis, and odd are symmetric to the origin. So you're seeing some examples here. This one is neither. Increasing, decreasing, and constant functions. So we're going to use the same graph we've been using. We're accustomed to it now. So increasing always means going up, decreasing going down. And we're looking at the graph from left to right all the time. You can see there's no constant here. Local minimum and local maximum. This is how we're writing it, okay? This local minima and maxima means those two that are changed, but not the furthest change. And when we have the absolute, we're looking at the furthest change that's available. Now, looking at average rate of change, I had to kind of stop and jump in here. We're looking at the change of x and the change of y. And we're plugging in the entire function into the problem. And you can see here where we did the functions and then plug them back into the problem to get the answer. All right, this is a great time to take a breather. For the next section, I won't be talking, you're just going to hear some nice music. It's actually our library of graph functions. And please feel free to pause the video at any point and jot down any information you may need. Whew. Well, Jane, I know. This is so much information. It's mind-boggling. But we're almost done. Now we're going to look at transformations. These graphs move all over the page. And so we're going to see what equations look like when they've moved. So here's some transformations. Graphs moves up, down, left, right. They become thinner, thicker, and they flip. So here's the original function. We're going to take this function and we're going to move it. We're going to use 2 as our number. So f of x plus b will shift this function. For us, it'll be 2 units upward. And you'll see in the graph. Yeah, there we go. The original graph is green. And I'm just taking this a little slower because this part was a little difficult for me just because I felt like I had to memorize it because things were happening so quickly. But we really don't have to memorize it if we jot down just these little notes. F of x minus b. You see how it went down? And again, the original graph is in green. So now we're going to take the graph to the left. So look at the parentheses. When it's inside the parentheses, we know we're moving left and right. Translate it to the left by 2 again. Your original graph is green. And remember, we're looking for what's inside the parentheses so that we know that we're moving left and right. F of x minus b shifts the function b units to the right. So this isn't as difficult as I thought it was initially. But when you don't really know what's happening, you can get thrown off. Now, we have a lot of different terms for this, but we're going to make the graph wider. So when we look at this graph, we'll see that the original graph is a little bit thinner and the newer graph is starting to open towards the x-axis, and that's how I saw it. It's getting wider. It's opening towards the x-axis. A lot of people have different terms for this. All right, so this stretching is going to make the graph thinner. It's going to begin to move towards the y-axis. You can see it there. The original graph is in green, and the new graph is moving up towards the y-axis. This is stretched. Well, Jane looks ready for Christmas. So a negative f of x reflects the function in the x-axis that is upside down. So we're just going to flip it all the way upside down. You see the original graph, and then you see it reflected over the x-axis completely flipped because it's the entire function that's negative. It's a negative f of x. And f of negative x, which doesn't mean the entire function is negative, it just means x. It reflects the function in the y-axis. So that means across the y-axis.